Introducing the Beacon, the latest advancement in medical technology that helps people dealing with some of today's toughest cranial health challenges, from epileptic seizures to cerebral palsy. This protective cranial helmet is designed to have an exterior line with scattered, overlapping carbon scales and a fibrous foam layer underneath it, just like the toucan's beak.
When I say toucan, what pops up in your head? Is it an image of the rainforest, maybe its colorful beak, or perhaps the fruity cereal it inspired? Well, as it turns out, the toucan's beak has amazing properties that aren't limited to just mascotting a cereal. The toucan's beak measures to be 1/3 of the bird's length, yet only 1/20th of its mass, and is used for eating fruits, insects, and carving nests in trees. In an effort to discover the key behind the stiffness of the toucan's beak, researchers sectioned the beak and performed numerous tests on strength, structure, and hardness. Our helmet, Beacon, takes inspiration from these findings to better protect the wearer's head. Using a lightweight carbon scale exterior, Beacon works synergistically with a shock-absorbing interior that models the closed-cell system of a toucan. Beacon also prevents crack propagation from local damaged regions. So how is Beacon like a toucan's beak? Just as toucans can fly with such large beaks, Beacon wearers will also be able to move quite freely. With safety as well as comfort in mind, we aim to produce a helmet that even toddlers can wear effortlessly. The foam layer results in high specific stiffness and strength, as well as reasonable energy absorption capacity, dampening, and insulation properties. As can be seen from the graph, the force level of the foam-filled shell is higher than the combined force of the shell and foam. This effect is referred to as the interaction effect, because the beak's energy absorption capacity and mechanical stability has increased significantly.
The section cut of toucan beak gives us an idea of how to build the exterior of the helmet more rigid. By designing or overlapping the shape of cobblestone on the helmet will reduce the impact of collision. The properties of exterior elliptical scales will be 5 cm long in horizontal axis and 4 cm radius in vertical axis. Choosing the lightweight materials will maintain the feature of toucan beak, low density, and high stiffness.
Tend to use the Beacon helmet to provide better protection and shock absorption to patients who acquire cranial helmets. The toucan beak was built to be lightweight and strong, thanks to the beak's rigid foam layer that is sandwiched between 2 hard layers of fibrous keratin scales. Upon designing our new helmet, we decided to incorporate these beak features into our helmet design. Thus, our helmet will be able to absorb any impacts in order to protect against cranial contusions. Some of the most popular helmet choices force patients to choose between protection or comfort. Oftentimes, the most protective helmets restrict head movements and are very heavy and large. On the other hand, the most comfortable cranial helmets can often be too soft to the point where they do not offer adequate protection or ventilation. As can be seen from our innovative design, our novel helmet is a combination of the positive aspects of both the current helmet choices.
Patients recovering from brain surgeries often suffer from symptoms like confusion, loss of function, and reduced mobility, which can increase risk of tripping or falling. Thus, a protective helmet is crucial in order to prevent re-injury during the healing process. Yet many patients forego wearing helmets simply because they are too bulky and uncomfortable, often turning to thinner, less protective cover-ups like scarves or turbans. Beacon provides the perfect solution for these patients, combining comfort, style, and protection with its toucan-inspired foam-line shock-absorbing properties.
Our next step is to collaborate with researchers and medical professionals to best suit the needs of our target demographic. By further studying the characteristics of toucan beaks with biomimetic researchers such as Yasuaki et al., we hope to accurately apply the shock-absorbing characteristics to our products. We also want to collaborate with existing companies that specialize in protective helmets such as Guardian helmets, Ortho America products, Comfy caps, and Opticool headgear. Because this is a medical device, we want to ensure it is as safe and durable as possible for our target demographic. Some roadblocks we may encounter are construction costs and slow production time. One way to address this problem is to consider 3D printing the helmets, which would also provide a faster turnaround from the time a patient submits their cranial specifications. In the future, we want to consider utilizing environmentally conscious material and using our product to address plagiocephaly.